warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we are going to discuss about one sample Z test. In the earlier video, I have shown you how to conduct a one sample t-test. We conduct a one sample t-test when we know the mean of the population, but we don't know the standard deviation of the population. But in case we know the standard deviation as well as the mean of the population, in that case, we are prescribed to do a one sample Z test. When you see and go into SPSS, there is no direct way to conduct Z test. We can do a Z test in SPSS using a syntax. So I'm going to show you in this video how to practically do a one sample Z test using a syntax which you can use to do this test. Let us start. One sample Z test is a statistical test used to determine if there exists a significant difference between a sample mean and the known population mean in case the population standard deviation is known. Sample size should be greater than 30. It's a parametric test, so it again depends upon certain assumptions, like the data should be normally distributed and there should be no outliers, and the observations should be independent of each other. You might like to go back into one sample t-test video and check on how to check the assumptions. In this video, I'll be directly taking you over to how to conduct a Z-test using a syntax in SPSS. This is the syntax command which we will be using in SPSS. Herein you can see what is this 50. 50 is the sample size in this case. 74.42 is the mean of the sample. 86 is the mean of the population. And 7 is the standard deviation of the population which is given to us. So we have to just enter these values in the syntax. So you might like to copy this syntax for your use and then you enter these values. So in this example, we have a problem, that is a university wants to test whether its students are performing differently from the national average score of 76. That means there is an exam conducted at a national level. Out of 100 marks, the national average was 76. A university wants to assess whether its own students who appeared for the exam, their average score is different from the national average, whether it's higher than the national average or lower than the national average. We are not just talking about higher and lower here, but we are also talking about being significantly higher or significantly lower. So that is why we are doing a Z test to statistically assess whether the mean score of the sample is different from the mean score of the population, especially in the case when the population standard deviation is also known to us. In t-test, in one sample t-test, you might recall that though we have the population mean, but this population standard deviation we don't know. In that case, we do a one sample t-test. But when we know the population mean as well as the standard deviation of the population, in that case, we go for a one sample Z test. So the null hypothesis in this case is there is no statistical difference between the sample mean and the population mean. Alternate hypothesis is there is a statistically significant difference between the sample mean and the population mean. So now let us go to SPSS onto our data and check it out how to do this thing practically. So here we are in our SPSS data sheet. We have 50 cases with us. You can see here case ID 50, and these are the marks of the students. 50 students' marks in that test. So how to do a one sample Z test? First, in order to do a one sample Z test, I should be knowing what is the mean of my data series. That means what is the mean of these 50 students' marks. For that purpose, I'll go to Analyze, Descriptive Statistics, and Explore. I'll shift the student marks to the dependent list, and in Statistics, I should have a tick done on Descriptive so that I can get the mean. Click on Continue and press OK. So I get the results. You see here the mean of the student marks is 74.42, and this is my sample mean. In case processing summary, I can see that there are no missing values, 0% of missing cases, and there are 50 valid cases. So the mean which I have is 74.42. Now I need to compare this mean of the sample with the population means and assess whether it's statistically significantly different or not. At the same time, I need to check the assumption of normality, skewness within the limits of -2 to +2, the absolute skewness value, the kurtosis absolute value within the limits of -3 to +2. So I can go ahead and say that my data exhibits normality and I can go for a Z test. This assumption of normality might not hold truly when the sample size is quite large. But in case the sample size is less, you must do an assessment of normality before going in for a one sample t test or a one sample z test. So now we do a one sample z test. For that purpose, I'll use a syntax. I'll go to File, New Syntax, and here I have to put the syntax which I showed you in the slide as well. So here 50 is the sample size, 74.42 is my mean of the sample, 76 is the mean of the population, and 3 is the given standard deviation. Now, I need to take care that this arrow which you see over here, black arrow, points towards this data which I have fed in here, and then I'll click on. So once this black arrow points on the data which I have clicked over here, I will go into active and check whether my data set is selected or not. So the name of the data set is dataset 1. As you can see over here, dataset 1. So I need to make sure that in the syntax active data sheet is selected, then only this will run. And once it is okay, the arrow is pointing towards the data numbers which I have fed in, and the active data sheet is okay. I just need to click in run all. So I'll get the results. These are my results. You see here, Z statistics minus 3.72. The p-value is lesser than 0.05. That means it is significant. And I reject the null hypothesis, which was there is no difference between the sample mean and the population mean. And I interpret, yes, there is a difference in the sample mean and the population mean. Thereby, I can say that the marks of the students which belong to a particular university significantly differ and they are lower as compared to the national average. They are significantly lower than the national average because the significance value is lesser than 0.05. So this value of Cohen's d tells me that the sample mean is 52.66 standard deviation lesser than the population's mean. So that is how I do a one sample Z test in SPSS and interpret the results. I hope the video was quite interesting and knowledgeable for you, and you will definitely recommend it to your friends and faculty colleagues. Thanks for watching and keep learning for more.